Welcome everyone. The question number 13 is the electric field E and the electric potential V at a point inside a charged hollow metallic sphere are respectively E equal to 0, V equal to 0, first option. Second option is E equal to 0, V equal to V naught, and V naught is a constant. Second option. Third option is E not equal to 0, V not equal to 0. And fourth option is E equal to E0, which is a constant, and V equal to 0. So among them, which one is the correct option? Obviously we have to write down, but before that, please try to understand some basic things. Metallic hollow spherical cell, maybe it is like this. It is of radius r with the center O. If it is charged, if some charge is given, then all the charges comes on the surface. Okay, all the charges comes on the surface. Now if anyone want to find it out, the electric field at any point outside, let us say at PO, which is at a distance RO from the center, that means at any outside point we can say, then we have to consider a spherical Gaussian surface like this. Spherical Gaussian surface like this, and cyclic integral E dot ds, we can say EO dot ds DSO equal to Q enclosed divided by epsilon naught. Okay, so in this particular case, obviously we can get the EO equal to Q divided by 4 pi epsilon naught r square if Q is the charge given here. But if you want to find it out, the electric field at any point inside, that is Pi, then we have to consider another spherical Gaussian surface of radius Ri. Okay, now if I apply this Gauss's law again, then EI dot DSI equal to Q enclosed divided by epsilon naught, then this will become EI multiplied by 4 pi Ri square. Q enclosed will be 0. Okay, as this Gaussian surface we have considered, it have not enclosed any charge, so we can say Q enclosed is 0. As the Q enclosed is 0, so obviously the right hand side Q enclosed divided by epsilon naught, that will be 0. If that is 0, so we can say very simply EI, which is electric field at any point inside the spherical cell, that will be 0. Okay, now if you want to find it out the potential at any point inside within the spherical cell, okay, spherical cell of radius r is there at any point inside, which is Pi. Okay, then what you have to do, you have to bring an plus 1 unit positive charge, okay, from infinity, plus 1 unit positive charge from infinity you have to bring. Okay, and if you have to bring, then some work you have to done. So at first you have to bring from infinity to the radius capital R. Okay, we can say E dot dr, electric field outside, plus now you are just placing it up to that point, from here to here at first you have done, then from the surface to the Ri is the distance, so capital R to Ri. Okay, EI dot dr. I have just segregated into two different paths because the electric field outside and inside are not same. Okay, so obviously here negative sign should be there because E naught and dr are opposite direction. Electric field is in the outward direction, but you are try to take it in the direction towards it. Okay, so these two are in opposite direction. So cos 180 degrees there, so minus 1 is there, so E naught dot dr basically becomes E naught minus E naught dr, and if I put the value, then this will be Q divided by 4 pi epsilon naught r square dr. And if I put it here from capital R to Ri, this will become 0. Why? Because EI is 0. So if you just do the dot product, it will basically turns to 0. Okay, so minus of Q divided by 4 pi epsilon naught can be taken outside the integration. Inside only R to the power minus 2 is there. Limit is infinity to R. So this will be minus of Q divided by 4 pi epsilon naught R to the power minus 2 plus 1 divided by minus 2 plus 1. Okay, what are the limits? Capital R and infinity. So this will become minus of Q divided by 4 pi epsilon 0 minus of 1 by R equal to R to infinity. So this will become minus of Q divided by 4 pi epsilon naught minus of 1 by R plus of 1 by infinity. So this will become Q divided by 4 pi epsilon naught capital R. Since capital R is the radius and it is a constant, so we can say this is a constant and that is V0. Okay, so here we have obtained electric field is 0 at any point inside, but the potential is not 0, that is V0, and that is a constant one. Okay, so here among the four options, E equal to 0 but V equal to V naught